welcome to the final video of our semester-long project about the existence of microclimates at the USGS station up at the Indiana Dunes. We're just going to go over the executive summary first. So within the executive summary, provided our project goals, which were to create a uniform data set, run a k-means algorithm that will identify clusters within the data, create a basic visual representation of our data, and then provide a data organizing structure that will be able to be replicated by staff members at the Indiana Dunes USGS station. So within here, we provided the methods. So again, what we did was we kind of looked at the data first and decided that we would need some kind of k-means clustering in order to find out what these individual clusters are. So we ran that k-means clustering algorithm. You can see the individual clusters are here, so 3 distinct clusters. Following that, we ended up running some more analytics on that. That's available to be found in our results section. And then we also decided to run a calculation which basically determines the diurnal temperature range, which we assigned as the variable delta T, which will essentially calculate how much it warms up or cools down throughout the day. And we were able to visually represent that on our delta T cluster right here. So kind of going back up a little bit to our background information. I'll kind of go over that a little bit. So let's go back to our home page. So we have a nice looking home page here and the background section. So on the background section, we talked about what exactly is a microclimate, which a microclimate again is like a kind of a subset within a larger climate where there's more variation in canopy cover, elevation, wind exposure, some other natural phenomena that makes that smaller climate different than the rest. And why do we really care about the microclimates? It's because we want to try to determine whether or not there's smaller microclimates that are more conducive for the Carter blue butterfly to survive, or even the pitcher's thistle. So we were able to reference a few interesting papers that kind of talked about methods to be able to find these microclimates within our larger climates. And then we also talked about even more methods, which we weren't able to really go into very much of the degree day calculations, but we were able to use the diurnal temperature range, which is a very easy calculation. Again, that was referenced in one of the papers that we looked over. So I will go back to I kind of talked about the methods a little bit. I will check out the results next. So the results section kind of covers a summary of our key findings, which are again that we were able to create a uniform data set, being able to use a Python script, which is given in the resources section. And then we were also able to find these distinct clusters, which in some ways they promoted the existence of a microclimate, in other ways they didn't. Unfortunately, we were unable to convincingly decide. We did say that there was a trend towards the existence of microclimates. So some of these graphs we're looking at, so this is the 3 individual clusters. You can see clusters here, here, and here, and these are separated, the colors are separated by the type of sensor. So you can see they're really well distributed. It's not like you have one type of sensor over here, one type, and one type. So well distributed sensors. This is a graph of the sensors over their locations. So these are the longitude and latitude locations of the different sensors. You can see there's not really a trend in terms of what clusters go along with one, except for maybe cluster 3 over here. It looks like is kind of centrally located over here. But other than that, there's not really much of a trend. So then what we did, we ran another clustering algorithm, which we used k is equal to 3 again. Unfortunately, things were a little bit more spread out this time. You can kind of see 3 clusters still, but not so much. Then also we did our delta T calculation, which is a really interesting graph. So you could see our cluster 1, 2, and 3. This is taken from the May to July of 2011 up there. And you can see here that we had very different delta T values, which is basically the maximum minus the min temperature value throughout the day, which was a very good indicator of the existence of microclimates. So this is really interesting to find out. In the future, we do plan on running some more kind of data visualization analytics on our different data, but unfortunately, by the end of this project, we weren't able to do as many. So I'll go back and I'll just kind of go over some of the screenshots, take you throughout our project. So again, that's that graph I just showed you. This is the individual clusters. You can see 1, 2, and 3. And then this is another visual representation of our clusters. So we'll get some really nice looking graphs. And using some of those techniques we've been able to learn in Data Science 151 so far. So I hope you enjoyed our project. I hope you kind of learned a little bit about what exactly a microclimate is, the meaning of a microclimate, why you really care, and some of the techniques that we can use to be able to analyze all this massive amount of data. And hopefully you'll be able to use these different tools on here and some of the findings we were able to find to do it yourself and then possibly try to replicate what we did and even find out more. Have a great